This is the third part of our Lisp chapter. We are going to talk about Lisp architecture. We are going to include in this session Lisp deployment and Lisp infrastructure. This is what Cisco calls a Lisp deployment. We have Lisp sites, non-Lisp sites, the Lisp core, and within the Lisp core we have the Lisp infrastructure. Let's go first with Lisp sites. This is where the hosts live. We have our end user devices living in Lisp sites. These are also known as endpoint ID space. We can use IPv4 addresses or IPv6 addresses for our end user devices. Cisco has extended this definition so we can also use MAC addresses. And then we have the Lisp non-sites. These are the parts of the network where we are not running Lisp. Examples of non-Lisp sites could be the data center, the internet, or for instance, the servers farm block. Next, we have the Lisp core. The Lisp core is also known as the RLOC domain because we are going to be running here an underlay protocol that is going to be in charge of advertising all the RLOC IP addresses throughout the core. We can use IPv4 addresses or IPv6 addresses for the RLOCs. In the Lisp core, we have the Lisp infrastructure. That is a set of devices that performed different roles. The first role we are going to talk about here is the ALS server. You need at least one ALS server within your deployment. It is mandatory to have at least one. You can create certain levels of hierarchy within your Lisp deployment with ALS servers. For instance, you can create endpoint ID summarization with ALS servers. In order to configure ALS servers, you will need to create a BRF that is going to be used only for the ALT service. Next, we have the map server. The map server is probably the most important device within a Lisp deployment because it holds the complete routing information base for Lisp. This routing information base is rather called the mapping database, or for some commands, it can also be referred to as site registration database. You can have more than one map server in order to have redundancy. Next, we have the map resolver. The map resolver is the device that is going to answer the question, what is the location of a certain ID? So, in other words, all the devices within the Lisp deployment are going to ask the map resolver what is the RLOC that corresponds to a certain endpoint ID. You may have more than one map resolver if you need redundancy. Next, we have the ETRs. ETRs stands for egress tunneling routers. They are called egress because they handle the traffic that comes out from the Lisp core and enters into a Lisp site. They are called tunneling because remember that Lisp creates tunnels within the core. So they are going to receive a tunnel traffic. They are going to de-encapsulate this traffic and they are going to deliver this traffic no longer protected by a tunnel into the Lisp site. Now, these ETRs may have several connections into the core. Remember that each wide area connection may become an RLOC, so they may represent one or more RLOCs in order to reach a particular endpoint ID. They are going to communicate these mappings to the map server. So thanks to ETRs within the Lisp domain, map servers can create a complete mapping database for the complete Lisp network. Next we have ITRs. ITRs stand for ingress tunneling routers. They are called ingress because they are going to handle the traffic that comes from a Lisp site into the core. And they are called tunneling because they are going to create a tunnel as this traffic is injected into the core network. In order to work, ITRs need to know what is the RLOC for a particular endpoint ID. So as traffic enters the ITR knows the destination, but it doesn't know the location. So they are going to ask the map resolver for that information. So the map resolver is going to be in charge of making sure that the ITR knows what is the RLOC for a particular EID. Once this information reaches the ITR can then create a tunnel that will have a destination IP of the destination RLOC for this destination endpoint ID. And at the same time, this router is going to hold that information into what we call a map cache. So if this router needs to continuously send traffic to this destination EID, this router does not have to continuously ask the map resolver for this RLOC to EID mapping. It will hold this mapping into the map cache until this entry times out after 24 hours. Then we have proxy ETRs for egress, as they are routers that manage traffic that comes out from the core into non-LISP sites. They mainly do not require too much configuration. You can choose one to become the default gateway for your LISP core as well. Next, we have proxy ITRs. The I comes from ingress because they are going to be routers that are going to manage traffic that comes from non-LISP sites into the LISP core. The proxy ITRs will have to communicate with map resolvers because they will need to know RLOCs, destination RLOCs for destination endpoints IDs. We are going to configure these proxy ITRs with a partial map cache, where we are going to let these proxy ITRs know what is the list of all endpoints IDs that live within this LISP deployment. Now, finally, we can perform some optimization for these devices that live within the LISP infrastructure. For instance, we can join several roles within a single device. We can use the same device to be a map server and a map resolver. So we have a map server, map resolver, and we can also configure this device to become the alt server. In the same manner, for these devices that connect LISP sites to the LISP core, if they are performing both functions as ETRs and ITRs, we can call them XTRs. In the same manner, for proxies, if they are moving traffic, ingress traffic and egress traffic, they are performing both functions, proxy ETRs and proxy ITRs. So we can call them, in that case, PXTRs. Now, this is a summary of what we saw. We talked about the LISP deployment that includes LISP sites, non-LISP sites, the LISP core. We talk about what devices make the LISP infrastructure that live within the core, that are alt servers, map servers and map resolvers, ETRs and ITRs, and proxy ETRs and proxy ITRs.